Hello everybody, and welcome to the conclusion of example 1 on page 86 of the workbook. Recall that in this example, what they're asking us to do is to basically enumerate all the possible abelian groups of a particular order. Okay, in part C, they'd like us to do that for the order 144. Okay, and again, we discovered that this comes down to prime factorizations and kind of the number of ways to break them down in some sense. So if you take 144 and factor it, you might notice that it breaks down into 9 times 16. And we can go a little bit farther and notice that 9 is 3 squared and 16 is 2 to the 4th. Okay, and I'm hoping that the numbers that you see there might remind you of a relationship to the previous parts of the problem. Okay, 3 squared and 2 to the 4th, those were exactly the two orders that we examined, okay, in parts A and B. B was about groups of order 16, and A was about groups of order 9. Okay, so we can actually use the answers that we already got in part A and B to help us to answer this question. How do we get an abelian group of order 144? Well, one way to think of it is we're just going to put one of our answers from part A together with one of our answers to part B. We need to count the number of ways that we can do that. Okay, so what were our answers to part A and B? We discovered that there are just two groups, two abelian groups of order 9, and there were 5 abelian groups of order 2 to the 4th. So that means that there should be 2 times 5 equals 10 total ways that we could do this for groups of order 144. Okay, so let's start by making that observation, then we'll see if we can write that out. Okay, write out all the possibilities. Okay, so using our above answers, there are 2 times 5 equals 10 of them. All right, and now we're going to do some writing. 10's kind of a big number here. Okay, we'll try to do this in an organized fashion. Okay, so let's start with one of our two answers from part A. Okay, so one of the two abelian groups of order 9 looked like Z9. And now we want to take that Z9 and just put it together with all of our answers from part B. All of the 5 ways that we could, all of the 5 different possibilities for abelian groups of order 16. Okay, so I'm literally just going to go right down this list from part B. All right, so starting with Z16, okay, then Z2 plus Z8, then Z4 plus Z4, okay, and then just continue until we're done with that list. All right, and so what we've got so far then is 5 of the 10. What would the other 5 look like? Okay, well, we would just start with the other group, the other abelian group of order 9, which looked like Z3 plus Z3, and we're going to take that Z3 plus Z3 and put it together one at a time with each of the 5 things on our list from part B. Okay, so starting with Z16, then Z2 plus Z8, and we just continue. Okay, so not the most exciting thing. This is a little bit tedious doing all of this, but the nice thing about it is that we know from the theorem that we've got a complete list. When we're done, we're going to have every single abelian group of order 144 that there could possibly be. Okay, and there is our complete list of all of the abelian groups of order 144. And you might, after you stop this video, you might think about kind of looking at a few of these and just convincing yourself based on the theorem that everything on our list really, and any two elements on our list are non-isomorphic.